So if you look at question 14, we are given the sets x is equal to 0, 1, and y is equal to 0, 1, 2. Check whether each of the following operations is a binary operation on x and y. The second question says, also check whether the operation is commutative and associative. So we have to check the operations that I've mentioned here. It's plus. Is it binary on x? Is it binary on y? Is it commutative? Is it associative? When you're done with plus, checking on x and checking on y, we'll come back and check if minus is binary on x. Is it binary on y? Is it commutative on x? Is it commutative? I mean, it's associative. And then we'll also go to multiplication, do the same, finally, division, and do the same. Okay, so let's talk about question 14 now. So question 14. So we have 14a. We want to start with plus. First, we put the sets x is equal to 0, 1. We also put y, which is 0, 1, 2. And then in answering part A, we'll start with checking, let's call it 1. We want to check if plus is binary on x. So on x, let's make the plus table for x. So suppose we put plus here. Remember very well when we were young, we had these, though they were called times tables. Now here we are trying to form the plus table, where I put the number 0 here. I put the number 1 here. I put the number 0 here. I put the number 1. Then you want to add 0 plus 0 will give us 0, and 0. So when I say 0 plus 1, we'll get a 1, and then 1 plus 0, we get a 1, and then 1 plus 1, we get a 2. So we have formed the table. Now we want to use this table to make a conclusion as to whether plus is binary on x or not. Now, plus will be binary on x if for every element, if for every 2 elements, from x when added are giving a solution in x. So I'm trying to say, we are going to say plus is binary on x if it happens that whenever you pick an element, whenever we pick 2 elements from the set of x, for example, we have 0 and 0. When we added, we get 0. Then we check, do we find this 0 in the set x? Yes. Next, we get 0, we get 1. When we add them, we find 1. Do we find 1 in X? Yes. We come to 1 and 0. When we add them, we get 1. Do we find 1 in X? Yes. Okay. We get 1 and 1. The number can repeat itself. There's no problem. When we add 1 and 1, we get 2. Is 2 in X? We don't find 2 in X. Now, because we have not found 2 in X, then we say plus. So we are saying plus is not binary on X because 1 plus 1 is equal to 2, but 2 is not in X. So we have given a reason. For it to be called binary, it must be that whatever you do, any numbers that you get, whatever you do to them, the answer must be in the set X. You cannot use a number that is not in X. But when you are done, your answer again must be in X. Now here we have found the 2, which is not in X. So let's go again. Let's check if plus is binary on Y. Okay. Or maybe we can first finish on X. Is it commutative? Let's check if plus is commutative. So is plus commutative? On X. Let's check. Now, for plus to be commutative, we want A plus B to be equal to B plus A for every A and B coming from X. Is that the case? Wow. If you are using a table, you just check if you have this symmetry. I have 1 here, 1 there. And then, well, if there was another one, would have had 2 there. Then you know that it's commutative. Or you can check. You said 0 plus 1 is the same thing as 1 plus 0. What else? Nothing, because when I say 0 plus 0, it's the same thing as 0 plus 0. 1 plus 1, there's no switch there. So because this is the same, and it was the only variation that we have, then plus is commutative on X. So I've checked. So this is B. And on the same B is plus associative on X. Now to be associative, we want, oh, there's a question.
Yes, sir. I wanted to ask on the part of being commutative.
Mm-hmm.
You only say 0 plus 1. You can't say 1 plus 1 like we've done it here.
No, what I said is, well, when you say 1 plus 1, you want it to be equal to 1 plus 1. You have switched the ones. Are we seeing any difference?
Yes, yes. Okay.
So we're saying, oh, it doesn't make sense when I switch 1 plus 1. It's the same thing. So then the interest here would be, if I get 2 different numbers, do I get a different answer if I switch how I add?
Okay. Okay. Thank you.
Let's check now. Is plus commutative, is plus associative? Is plus associative on X. Now, for it to be associative, we are asking this question: is A plus B plus C the same thing as A plus B plus C? That is what we check. Now, addition of this nature will be associative, because look at the numbers we have. Suppose I pick 0 plus 1, and then I add 1. The answer will be 1 plus 1, which is 2. Now, if we pick 0 plus 1 plus 1, we will get 0 plus 2, which is 2. So for such an arrangement, whichever way I switch the numbers, whichever way I pair my addition, I will still get the same value. So this means that plus is associative on X. So we needed to check if it's binary on X. If it is or not, you also comment on, is it commutative? If it is or not, you also comment on, is it associative? Plus go through X in being binary, commutative, associative. Okay, so we have exhausted plus on X. The task I give you is to exhaust plus on Y. Most of the conclusions will be the same. In fact, all of them. But now I want you to make the table and then do the checking throughout like this. So now we'll go to the second operation, which is minus, and we'll do it on Y. So now let's do the operation on Y. So on Y, remember, Y is 0, 1, 2. Then we want to do the operation here. So we're using minus. So let's form a table for minus, 0, 1, 2. 0, 1, 2. Does it make sense? Let's check. 0 minus 0, so 0 minus 0, we get 0. Maybe let me put the solution in a way. So we get 0. Then 0 minus 1, 0 minus 1, we'll get minus 1. 0 minus 2, we'll get minus 2. 1 minus 0, we'll get 1. And then 1 minus 1, we get 0. Then 1 minus 2, we get minus 1. 2 minus 0, we get 2. Then 2 minus 1, we get 1. 2 minus 2, we get 0. Then you check, have I seen anything strange? Strange is, are all the numbers in red? Do they all belong to Y? As we can see, we have -1, we have -2, which are not members of Y. So because -2 and -1 do not belong to Y, minus is not binary on Y. So if I find a number that does not belong to Y, then minus fails to be binary on Y. We needed to have all the red numbers belonging to Y. Okay. Is it commutative? Well, we still go on and check if it's commutative, even if it's not binary. As you could see in the first one, it was not binary, but we went on to check if it was commutative, and it ended up being commutative. So now we check, is minus commutative? On Y. Let's check. So we can use the same numbers. Now, remember in the previous one, I said, if you are able to do this and the numbers are the same, then it's binary, and then it's commutative. This time around, when you do this, the numbers are different. Then you know that it's not commutative. So you can pick that as your example. You say, oh, if I pick 0 minus 1, the answer is -1. But if I pick 1 minus 0, the answer is 1. So when you switch, the answers differ. For it to be commutative, even if you switch, the answers must be the same. Now, when I switch, the answers differ. What does it mean? It means minus is not commutative on Y. Okay, because you can cite an example, 0 minus 1, which is equal to, or 0 minus 1 is not equal to 1 minus 0. Let's go. So when I switch, I get different solutions. So it fails to be commutative. Another question is it associative? Is minus associative? On Y. Let's check. So say, well, we want, if we have A minus B minus C, is it the same thing as A minus B minus C? Let's pick numbers. We have 3 numbers here, so we'll pick without repeating any. So let's do 0 minus 1 minus 2. What we get? Here we'll get 0 minus 1 is -1, and then -2, giving us -3. Okay. What about 0 minus 1 minus 2? What we get? This will be 0 minus 1 minus 2, giving us -1. So 0 minus -1, we get 1. So what do we see? So we are saying, oh, since 0 minus 1 minus 2 is not equal to 0 minus 1 minus 2, then minus is not associative. Then,
Sir, looking at what you said, that there to prove that if minus is associative on Y, we've used elements in set Y. What of when we're using the plus to prove if it's associative on set X? What elements did we use? Because we also had C. So looking at the elements, we only had 2 elements. Which element did we use to represent C?
So we repeated 1.
Oh, so it's okay to repeat the element?
Yes.
Okay, thank you.
So that's why even in the addition, if you check, we had 1 plus 1 giving us 2, meaning 1 was used twice. Yeah, so that was about minus. We've done it on Y. As you try to see if you have understood the concept, you try it. So you do minus on X. So when you reach on associative apart, you repeat one of the elements, whether you repeat 0 or 1. So the next, we want to check if division. So now we'll go back to X and check for division. So we want to check division on X. So let's form a division table on X. So we'll have division, pick 0 and 1, 0 and 1. So now we have, what is 0 divided by 0? When you divide 0, when you say divide, like the same as this. If you have a calculator and try to punch, we trust a scientific calculator. So 0 divided by 0. Here it's saying mark error. The reason is simple. No one knows the fact. So the other way of answering that is to say it's undefined. So it's undefined. The same thing will be, so if I say 0 over 1, then I'll get 0. 1 over 0, again, undefined. But 1 over 1 is 1. The numbers that we have found, 0 and 1, belong to X. But undefined does not belong to X. So because undefined does not belong to X, we don't know what it means in the set X. So it means that division is not binary on X, since 0 divided by 0 is undefined. We can cite even just one example. Though we have several of them, we could also cite 1 over 0. But it's enough to cite one for the situation. Let's see. Is division commutative? Is it commutative? Let's check. So we'll have, remember, we want to check if A divided by B is equal to B divided by A. So let's pick the numbers we have. 0 divided by 1. 0 divided by 1 is equal to 0. But 1 divided by 0 is undefined. Are the two equal? No. So we say, since A divided by B is not equal to B divided by A, division is not commutative. On X. In a similar manner, we'll check if division is associative. On X. So let's check. So we'll have, remember we want A divided by B and then divided by C to be equal to A divided by B divided by C. Is that the case? Let's check. Let's pick numbers. 0 divided by 1 divided by 1. Let's use the same one. We repeat 1. What we get? We get 0 divided by 1, that is 0. Divided by 1 is still giving us 0. What about 0 divided by 1 divided by 1? So we have 0 divided by 1 divided by 1. So 1 divided by 1, that is 1. So we get 0. Well, when you are trying to justify and you have used one pair and it works, you must not be quick to end your checking. You also see what would happen if we repeated 0. Divided by 0. Here we'll get 0 divided by 1, that is 0, divided by 0, that I'm fine. Then you check also, what about 0 divided by 1 divided by 0? So we'll have 0 divided by 0, which is undefined. So this is telling us that, well, in whichever way we arrange them, division still gives us the same thing. So we'll say division is associative. On X. Since A divided by B divided by C is equal to A divided by B divided by C. Okay. The last thing we check is multiplication. So let's check multiplication on Y. Okay. Also, before I forget here, some of you were also asking if these lessons are also there for chemistry, for physics, I don't know, some for biology, math. Okay, so this one will have, but those who are also asking for chemistry, physics, biology, we have them under abundance. So we have all the other three. So if you happen to need these three or any of these, I've received quite a number of those. These, you you can still call on this number, or just drop a WhatsApp message. So you say, no, I'm following up for payments and what. And when it's one, it's a bit costly, but for those who, I know most of you have only one, but maybe for other viewers who would want more than one or the right, if you do more than two, it's just 80 kwacha per course. If you do two, it can still be favorable in that way. So those who want physical or still online, we have in both, in any way that you need them. Okay, so let's get back to X on to multiplication on Y. So I'm used to seeing it as X. So now how do I write it? Like this, multiplication on Y. So we'll form the table. On Y, so I put multiplication here, and then 0, 1, 2. And then 0, 1, 2. So we multiply 0 by 0. So I'll use weight. 0 by 0, we get 0. 0 by 1, we get 0. 0 by 2, we get 0. 1 by 0, we get 0. 1 by 1, 1. 1 by 2, 2. And this one I use because it's 9 times table. So 2 by 0, 0. 2 by 1, 2. And 2 by 2, 4. Remember, what was Y? 0, 1, 2. Now we have a 4 which is not in Y. So multiplication is not binary on Y, since 4 is not a member of Y. If there is even 1, then it fails to be binary there. Let's solve a bit fast because we only have 4 minutes. So let's check, is multiplication commutative? So if you have A multiplied by B, it did the same thing as B multiplied by A. Obviously, yes, because as you can see, if we draw that thing I was saying, you have these numbers are the same. So apart from the central numbers, you have this 0 equal that 0. You have this 2 equal to 2. So it means that it's commutative. Or you can try to do an arrangement, 0 by 1 or 1 by 0, you get 0. 1 by 2 or 2 by 1, you get 2. So either way, for all this multiplication, you get the same. So we say multiplication is commutative, where on Y. Okay, since A multiplied by B is equal to B multiplied by A. Let's check again. Is multiplication associative? So if we pick 1 multiplied by, let's start with 0. 0 multiplied by 1 multiplied by 2 in this order, is it the same? Okay, let's say the solution. 0 by 1, we get 0. By 2, we get 0. Okay, does it differ if we start with 0, 1 by 2? If we do it in that order, where we have 0 first, by 1 by 2, we get 2. When we multiply, we get 0. So it gives the same solution for whatever combination. The position of the brackets does not change the solution. So we say, oh, multiplication is associative on Y, since any combination. So now I will use this multiplied by C is the same thing as A multiplied by B multiplied by C. So then it's in associative. So when these cards we are rejoining, we want to do question 15. So we see how many we're going to do there. So let's rejoin and do question 15. At least we need to go all the way up to 2. So let's be fast.